Hello friends, welcome back. Hearty welcome to you. Let's continue with the examples we are doing related to integrals of some particular functions of the format of integral of 1 by root of x square minus a square, or 1 by square root of a square minus x square, or 1 by square root of x square plus a square. So we have a problem to solve. Let's try to solve it together. We have been given, we have to find out the integral of dx integral of 1 by square root of 8 plus 3x minus x square. Now we know that we have to convert this into one of the format. Which format it will fit into? We see that the x square is having negative sign. That means this will be fitting into the formula integral of 1 by square root of a square minus x square, which is equal to sine inverse x by a. So we'll see how we can do that. For that, what we will do, first we'll try to convert this 8 plus 3x minus x square into a square minus x square format in the right side. So I'll take this place and I'll try to do that. First we will say 8 plus 3x minus x square. So can I write it as 8 minus of x square minus 3x, because this gives me more comfort. I know that a square minus 2ab. So I'll leave 8 as it is. I'll go to the next step and say x square minus a square minus 2 into x, and b should be 3 by 2. So I have to add 3 by 2 whole square, and then I have to subtract again minus 3 by 2 whole square. This whole thing we have to do. So what it will become now? It will become 8 minus x minus 3 by 2 whole square minus 9 by 4. So can I write it as 8 plus 9 by 4 minus x minus 3 by 2 whole square. So can I take LCM and say 41 by 4 minus x minus 3 by 2 whole square. Let us see how we did that. We see minus x square, so we took minus out. We got a square minus 2ab terms. We saw that b is 3 by 2. So we have to add b square and subtract b square. Now this whole part will become x minus 3 by 2 whole square. This is minus 9 by 4. Now I do minus of minus becomes plus. You take the constant term out. You have 41 by 4 minus x minus 3 by 2 whole square. So we are ready now. We can go back to the problem and say dx divided by square root of 41 by 4 minus x minus 3 by 2 whole square, which is equal to integral of, can I say dx by, now 41 by 4, how I can write it as a square? I can say root 41 by 2 whole square. I can say root 41 by 2 whole square. Let me write it in a little bigger numbers. Root 41 by 2 whole square minus x minus 3 by 2 whole square. Now we are in the form of dx by square root of a square minus x square, where a equal to root of 41 by 2 and x equal to x minus 3 by 2. If I take x minus 3 by 2 equal to t, I will have dx equal to dt. So everything will remain as it is. So the next step will be integral of this is sine inverse x by a. I will write it as sine inverse of x is x minus 3 by 2 divided by a. A is root of 41 by 2. If you take LCM and simplify, you will get sine inverse of 2x minus 3 divided by root 41 plus c. So that is the answer we have. So we have to look into if the sign of the x square term is positive or negative. If it is positive, that means it will go into x square plus a square or x square minus a square format. If it is negative, then it will certainly will go into a square minus x square only. Let's do one more problem. We have been asked to find out the integral of 6x plus 7 divided by x minus 5 into x minus 4. What I will do first, I will try to multiply this, and I will say that's nothing but equal to 6x plus 7 dx divided by x minus a into x minus b, x square minus 5x minus 4x is minus 9x plus 20. So can I say x square minus 9x plus 20 now? Okay. Now, how to do this problem? You remember this is of the format of integral of px plus q divided by, actually we have a square root. I just missed a square root here. Let me just place it. So it's of the format of px plus q divided by square root of ax square plus bx plus c. You know what to do in that. We have to, how we will do that? Let's write it down. We will write it, we'll do it as, we'll give the steps. Integral of px plus q by root of ax square plus bx plus c. The method is to write it as a times d by dx of ax square plus bx plus c, or can I say 2ax plus b divided by root of ax square plus bx plus c. Now you know that whenever you see something like this, it will become 2 root f of x. 2 into root of f of x. If this is f of x, you have f dash x by root of fx, then it is 2 root fx. You are aware of that already. Plus b, then we have integral of dx by root of ax square plus bx plus c. Now our first job is to find out the values of a and b. So I will write it down. 6x plus 7 is equal to a into, what is the d by dx of x square minus 9x plus 20? X square is 2x, 9x is minus 9x is minus 9 plus b. So from here I have to get the values now. I will equate first x terms. I will say 6 equal to 2a, that will give me a equal to 3. Now I go to the other side. I'll check the constants here. 7 equal to minus 9a plus b and here we have 6x is equal to 2a, 6 equal to 2a. So let's try to calculate the value of b now. 7 equal to minus 9 into 3 plus b, or can I say b equal to 7 plus 27, that's equal to 34. So we found out that the value of a is equal to 3 and the value of b is equal to 34. So we'll divide this into two parts now. So we'll rewrite, once we found the a and b values, we'll rewrite as integral of 6x plus 7 dx by square root of x square minus 9x plus 20 is equal to, we got a equal to 3, so we can say 3 integral of 2x minus 9, that's a d by dx of ax square plus bx plus c, or it is x square minus 9x plus 20 divided by square root of x square minus 9x plus 20 plus 34 dx divided by square root of x square minus 9x plus 20. We will divide this into two parts. This we call it as I1 and this we call it as I2. So we have integral in the second part also. Yes. So first we will do I1. When I go to I1, I will have 3 integral of f dash x divided by root fx. We know that is equal to 2 root fx. We know that integral of f dash x by root of fx is 2 root fx. Therefore, I1 will be nothing but equal to 3 into 2 into root of fx. Root of fx is root of x square minus 9x plus 20. Or can we also say here, instead of f dash x, suppose let's put down the original values. We will say integral of f dash x, that is 2x minus 9 dx divided by root of f of x, that is x square minus 9x plus 20, is equal to 2 root of x square minus 9x plus 20. How that comes? We take x square minus 9x plus 20 equal to t. We directly have the formula, but we'll see how to do that. We take x square minus 9x plus 20 equal to t. Then we'll have 2x minus 9 dx equal to dt. So you got dt by root t, which is equal to 2 root t. So this is part of I1. Now let's go to I2. Let's do I2 part now. I2 will be I2 equal to integral of 34 we will take out. We'll have dx by x square minus 9x plus 20. So we have to now use completing the squares method, and we will write it as dx by x minus 9 by 2 whole square plus 20 minus 81 by 4. What I did is, this is a square minus 2ab. b square term is 9 by 2 whole square. So I have just skipped a couple of steps here, but you should be able to follow that. X minus 9 by 2 whole square plus 20 minus 81 by 4. That's equal to 34. Integral dx by x minus 9 by 2 minus 1 by 2 whole square. So this is of the format of integral of 1 by integral of root of x square minus a square, and we know the formula is for that log of x plus root of x square minus a square. So the answer is 34 log x is x minus 9 by 2, x minus 9 by 2 plus root of x square minus a square is whatever the problem given to us, that is x square minus 9x plus 20. So this will go into I2 part instead of here. So let's try to simplify, let's try to erase this and substitute with our answer. The answer will be plus 34 log of x minus 9 by 2 plus root of x square minus 9x plus 20, everything in brackets. So that is our answer. So we have to use the formula that whenever we have px plus q by root of ax square plus bx plus c, we will write it as capital A into d by dx of ax square plus bx plus c divided by root of ax square plus bx plus c plus capital B, that's another constant, into dx by. So basically what we are trying to do is, whatever the numerator is there, we are trying to convert into a combination of some times of the derivative of the function and another constant, so that if it is a constant, I can convert them into one of the standard form. When you have derivative in the numerator, you know, obviously with method of substitution you can directly find out the integral of that. Let's do one more before we wrap this up. We have to find out the integral of x plus 2 divided by square root of x square plus 2x plus 3. So we will do the same formula here. Now the first step is to find out the a and b values. For that, what we do, we write numerator x plus 2 equal to a into derivative of the function, that's nothing but x square derivative is 2x and 2x derivative is 2. plus b. We have to find out the values of a and b now. So what we will do now, we will compare them. We will say 1 x term is 1 equal to 2a, that is one condition. Another condition is 2 equal to constant term 2 equal to 2 into a 2a plus b. So if 2a equal to 1, that gives me a equal to 1 by 2. If I know a equal to 1 by 2, then b will be nothing but equal to 2 minus 2 into a, that's 1 by 2, which is nothing but equal to 1. So we got a equal to 1 by 2, comma b equal to 1. So let's write down. So we can write down this function once we know the values of a and b. We can say 1 by 2 integral of 2x plus 2 dx divided by square root of x square plus 2x plus 3 plus dx by b is 1, so we don't need to multiply. We'll have x square plus 2x plus 3. Okay, now we divide that into two parts. Now by this time you are pretty much conversant with that, so I'll do it very quickly. Now this is f dash x and we have here f of x. F dash x by f of x, root of f of x is nothing but integral is, we know that that's nothing but equal to 2 root f x. So I can say half into 2 into root of x square plus 2x plus 3 plus, we have integral there, I just missed the integral part here, plus integral of dx by x square plus 2x plus 3. I can write it as x plus 1 whole square plus root 2 whole square, because x square plus 2x plus 1, 2 is left out, can be written as root 2 whole square. So this is of the form of dx by x square plus a square with a square root. We know the formula is log of x plus root of x square plus a square. So we'll try to go to the next step. We'll cancel 2 and 2. We will say the next step is equal to root of x square plus 2x plus 3 plus, we have log of, integral is log of x plus 1 plus root of x square plus 2x plus 3. So we have skipped so many steps, but we have done so many problems. Now it should be easy for you to understand the steps directly. So we have now f of x and f dash x. If you want, you can write down this is of the form of f dash x by root of f of x. Therefore its integral equal to root of fx. So that's 2 root fx. So 2 will cancel. You will get root of fx here. Plus this is of the form of root of x square plus a square. So you can write it as log of x plus root of x square plus a square. So we'll do one more problem before we wrap this up. We have to find out the integral of 5x plus 3 dx by square root of x square plus 4x plus 10. So first we have to find out a, b values. So first we'll write down what we want to do with this now. We want to divide this into two parts. A integral d by dx of x square plus 4x plus 10. Then we have in the denominator square root of x square plus 4x plus 10. Then we have plus b. Then integral of dx by square root of x square plus 4x plus 10. Now we'll go to the next step. First we have to find out the values of a and b. So let's write it down. 5x plus 3 is equal to a into derivative of x square plus 4x is 2x plus 4 plus b. We will equate the terms. First we'll equate the x terms. X term equate, we get 5 equal to 2a or a equal to 5 by 2. The next equation we will compare the constant terms, a into 4 and the b here. So we'll have 3 equal to 4a plus b. We know already a equal to 5 by 2. So 4 into 5 by 2 plus b, or can I say 3 minus 10 equal to b, or b equal to minus 7. So we got a equal to 5 by 2 and b equal to minus 7. We can just go and substitute them. We can say a equal to 5 by 2 and b is equal to minus 7. So let me write down that minus 7. So that is taken care. Then we can go back and start with the next step. So the next step will be 5 by 2. We know that integral of f dash x by root of fx is 2 root fx. So I can say 2 root x square plus 4x plus 10, and I will have minus 7 dx by root of x square plus 4x plus 10. I can write it as x square plus 4x plus 4 plus root 6 whole square, because x square plus 4x plus 4 plus 6, that should be okay. I think, let me just check that. X square plus 4x plus 10 is okay. Yes. Now 2 will cancel. So next step will be 5 root of x square plus 4x plus 10 minus 7. We know the integral of d 1 by root of x square plus a square. There is root here, we missed it. So that will be nothing but log x plus, that is x plus 2 here, plus root of x square minus a square, that is x square plus a square actually, that is nothing but x square plus 4x plus 10 plus c. That's our answer. So our answer is 5 root x square plus 4x plus 10 minus 7 log x plus 2 plus root of x square plus 4x plus 10. So the point we have to understand is we have to see what type of format this particular problem is in. See, we have started initially by taking derivative and antiderivative logic. After some time that logic is not working. So we have to look into the ways how we can find out the integrals. So for that we have learned some special type of functions now, that is integral of 1 by x square minus a square, 1 by a square minus x square, 1 by x square plus a square, and also 3 more with square roots with them. So there are 6 formulas which we have learned, and these 6 formulas, based on that we have done some examples. So in the next session we will see how to do integration by partial fractions, and also we will look into most interesting and exciting part, that's integration by parts, where we will learn how to deal with functions where we have product or quotient of two functions. What is the provision in integration to find out the integral of two functions when you multiply them or divide them. That we will look into in the coming session. Thanks for your time and support. Please let me know your feedback. Bye for now.